We're in video 48, regression review, and I don't know why I'm pulling that up. Okay, and we're gonna go into another fun, amazing Fathom demonstration.
Cool. All right, let's do it.
Mr. Miller loves his Fathom.
Yes, I do.
Okay,
You get to move the bats around.
I do.
You get to see how the line fits, changes, and the correlation. It's all there. Okay, so we have some data here, and the red point is the outlier we're going to move around.
Yes.
This vertical blue line, that is drawn at the average x value. And so remember, a point has high leverage if it's far from that blue line horizontally. Mm-hmm. So we add that to the graph to kind of help us. And then we have the line of best fit drawn. That's the lighter line right there. So the first thing we're going to talk about is how slope changes as we move the line around. So Mr. Lewis, could you move the red point kind of in the middle of the pattern? Let's start down here. So that's kind of like what the directional line would pretty much be going without an outlier. And it looks like the slope is
0.68?
Yeah, 0.68. Right. Okay, Mr. Lewis is going to move it straight up and see how the slope is affected. So as you see, this point has no leverage right now. It's right on the average line. So as we move it up, it pulls the line up or down, but doesn't change the slope radically.
Yes.
So it changes a little bit, but it's not very influential, even though it has a high residual. But the moment, so if you can move it up a little bit, the moment we move it to the left of the line, see how it becomes influential. It starts pulling up the left side of the line. It's because it has leverage. It pulls up the left side of the line, and the right side of the line kind of goes down. And then we move it on the other side, same thing. As we give it more and more leverage, the average value changes. That's why it's moving a little bit.
Yeah.
Because we're changing the average value when we move this point. But when we move it above the overall average, the line gets pulled towards it. So here the slope is made very high, and if you move it all the way down, that point with high leverage can even change the direction of the pattern.
Yes.
Okay, so what really matters is the leverage as far as affecting the slope, I believe. Okay.
Yeah.
So if you can put it back in the middle, we'll kind of see what's going on with correlation. So the original correlation, or at least R squared is not the correlation, it's a fancy name. Variable, right, the coefficient of determination.
Right.
What a name.
It's the variation.
But it tells us how good the fit is, all right?
Yeah.
And it's related to R. So R squared is 35%. This is what this program gives us. So R squared is 30.35. Now, as you move it up, and we make it so it's a point with a high residual, you see it really weakens the correlation.
Yeah, because now the data is not all near the line.
Right. And then so the slope isn't changing a lot, but the strength of the pattern is getting weaker and weaker. What happens as you give it some leverage?
I give it some leverage. Well, so if I move it straight out on the line, it stays about the same. But as I leverage it up, it's going to get weaker again. Right?
That is 0.65.
Oh, no, I'm sorry. Yeah. It's going to get stronger. My bad.
So when we're out here, it kind of pulls the line towards it, and it kind of artificially inflates the correlation, makes it seem like the pattern is stronger than it is.
Yes.
But I think if you go back in this direction over here, then R goes down because it's outside of the pattern. But if it's anywhere kind of along the pattern, it has a tendency to kind of deceptively increase the correlation. Okay, it makes it seem like it's a stronger pattern than it is.
However, if I drop it way below, this leverage weakens it a lot.
Yeah. Right. Because it's not in the line.
Right. Because the original line was positive and now we're negative.
Now, so there are a lot of gray areas, but on a quiz, and I think on the AP test examples I've seen, it's very clear. You know, it'll dramatically affect the line or it won't. So if it's kind of along the line of the data, it can actually strengthen the correlation.
Yep.
Okay. All right. So hopefully that helps.
All right.
That was another amazing Fathom demonstration.
It was.
All right. Now, for a couple examples. Mr. Lewis, what do we have here?
All right. Well, we have people swimming the lake.
Lake Ontario?
It's kind of cold.
Is it like Lake Michigan, probably?
Smaller.
Yeah, good. Lake Michigan would be a feat. I don't know if anyone's swam across there.
So we might be interested to whether they're getting any faster or slower. So we looked at people from the years 1974 to 2004, and they recorded their times, and we wanted to know kind of what was going on. So they gave us a printout of our line of best fit, and you see the R squared. So this is not very.
7%.
Yeah, it's not very good.
That's kind of underachieving.
Yeah, this data isn't telling us anything, but we're going to still go with it. And then we have our residual plot. And you see we do have a pretty high residual.
Actually, these are fairly high themselves. So notice this is a residual plot.
This is
That's
the
a
zero
nice
line.
scatter.
Yeah.
But look at the scale of the residuals.
Yeah, but that's just in like the data. But you are right. So that's a really high residual.
Well, the reason why I think the scale matters is, like you said, R squared is very low. So there's still, even though you can fit it with the line of best fit, there's still a ton of variation about the line. It's a very weak pattern.
So what does the R squared mean? Well, we can write our fancy dancy, sentence about variation being explained.
You're not going to, are you?
No, I'm pretty much just going to say that the R squared for this data means that very little of the variation can be explained by this.
All right, I'll give the official sentence. Here it goes.
Okay.
7% of the variation in swimming times can be explained by... I should read the problem.
Year.
Thank you. I was getting in trouble. You know why?
Because this is a
residual plot,
yeah.
And that's not the X value there. I'm like, wait a minute. Yeah, so 7% of the time in minutes can be explained by the year, which is not a whole lot of explanation.
No.
Okay.
Not at all.
B, are the swimmers getting faster or slower?
Yeah, this is kind of a tricky question because they're starting to. This is a positive line, so they're taking more time. So I would answer it. They are getting slower.
They are.
All right, you'd kind of be like, "Oh, that's positive." So everyone's getting faster, and you would think they'd get faster.
I don't know if this is an
but
average for people or what. So,
I think these are just random people who do this.
Yeah.
I can't believe a lot of people are swimming across Lake Ontario.
No.
So yeah, it'd be slower because the times are increasing. Okay, so here we have the outlier up here, and they describe who it was.
Vicky Keith, man.
Some crazy chick who swam round trip, north to south, and then back again.
She didn't get that she was only supposed to go one way.
I think she needs a hobby.
And no one picked her up. So she swam back.
So, do you think removing this would change the model? Explain.
Well, now remember, this is not the data, the scatter plot. This is the residual plot.
Right.
But I do see,
Well,
I don't know.
this is a high residual, so we looked from our Fathom demonstration. This probably isn't going to change our slope a whole lot.
Yeah.
But it is going to change our R squared. It might that should improve once this is out.
Yeah, very
That
good.
should go up. But yeah, our slope probably won't change a whole lot.
No. Okay, what else?
And then D. So here's the new regression. Let's see if we kind of predicted that right.
Ooh, Mr. Lewis.
And we did.
But the old slope was 15.3, I think.
Right.
And the new slope is 14.9, which is pretty close. So R squared got a little bit better because we removed something with a high residual.
Right.
It's still not fantastic.
No, but it almost doubled. So
Yeah.
we definitely did better.
And the slope is about the same.
Mm-hmm. Yeah, it improved a little bit. Or actually, I'm sorry, it went down a little bit, but not much. So would you be willing to say the swimmers were getting faster or slower? I'm still going to say they're getting slower.
That's what the model indicates.
Yeah.
But, yeah.
I don't know why they asked that twice, but whatever.
Well, because they thought maybe removing the outlier would change things. But it didn't change things that much.
I guess.
Okay.
I think you're giving them too much credit.
All right. I tried.
All right.
Example number 2. We'd like to thank whoever came up with this and posted it on the internet so we could steal it. One measure of the success of knee surgery is post-surgical range of motion for the knee joint following a knee dislocation. So the explanatory variable is the age of the person. We got a youngster at 45 there, and the rest are even younger. And then the range of motion. So, okay, that's the response. Do any of the points appear to be influential? Okay, so...
Well, here's the original chart from up here.
Right.
And here is one where we removed this guy up here.
Does it seem to be? It seems like it makes a difference.
I think it makes a big difference.
What kind of difference did it make?
Well, A, our slope went down.
Dramatically.
Yes, and B, our R squared also went down a lot.
Yeah. So this is kind of weird. That point artificially strengthened the correlation.
Yeah.
So taking it out affected the slope, and because this pattern wasn't so strong to begin with, it went back to not being strong. So this actually strengthened the pattern.
Yeah. And it gives you a false
sense of patternness.
Yeah, it gives you a false sense that you can accurately predict things when you most likely are not going to be able to accurately predict much.
Right. Very good. So it was definitely influential.
Okay.
All right.
So,
Well, we're getting to the time of the year where, I don't know,
we want some feedback.
it's time to get in touch.
You have both, we had to be observed by our assistant principal, and now we want your feedback as well.
Okay.
So, we want you to write your favorite thing about stats classes so far, and then what's your least favorite thing, or even like what we could do to maybe improve stuff.
Okay.
If we're going too fast, too slow, so on and so forth.
Are we going to give them extra credit if they come up with their own stat rap, or is that later in the year?
Let's push that for later.
Okay, we'll save that for Christmas.